This hearing will come to order. Without objection, the chair is authorized to declare recess at any time. Good morning, everybody. Welcome to today's hearing, which is entitled The Future of ARPA-E. I'd like to thank our panel of expert witnesses for appearing with us today. In my district and in many around the country, the topic of today's hearing, which is energy and energy research, means cutting-edge science, but it also means jobs that support entire families. We must make sure that the U.S. remains a leader in this industry, and I look forward to working with members from both parties to do that. And in fact, today we're here to discuss a great bipartisan success, which is the future of the Advanced Research Program Agency Energy, or ARPA-E. I think it's helpful for us to look at how this program was started. Almost 15 years ago, a bipartisan group of members from the House and Senate were worried that the United States' competitiveness in science and technology might be falling behind. So they did a smart thing, which was they commissioned a report from the National Academies to suggest how the federal government could continue to maintain leadership in these areas. The report was called Rising Above the Gathering Storm, Energizing and Employing America for a Brighter Economic Future, and it did show that we were quickly losing our scientific and technological advantages. One of the major recommendations was the creation of a new program within DOE, which became ARPA-E. It was modeled on DARPA from the Department of Defense, which has been essential to revolutionary technologies like GPS and the internet. So we created ARPA-E with that same program in mind. We did something that people may think we in Washington don't know how to do, which is to double down on a government success, but that's what we're doing, and that's what we're trying to do here again today. We need to encourage innovation and paradigm-shifting discoveries in all sectors of our economy, but especially energy. The United States has consistently demonstrated throughout its history that our greatest resource is its people and their ability to innovate and lead, and we view that ARPA-E is a critical component of spurring that type of innovation. Congress first authorized this program in 2007, and I've been told that it was largely due to the hard work of one person who we are lucky enough to have in the room today, which is the chairman of this very committee at the time, Bart Gordon, who is sitting back and to my left. Chairman Gordon, thank you very much for your efforts and for being with us here today. Since then, ARPA-E projects have led to 71 new companies, 109 projects partnered with other government agencies, and 136 projects that have garnered more than $2.6 billion in private sector funding. And as we're going to talk about today, that is more than the government has spent on ARPA-E in that time. Among these projects is one that I'm very proud of. It's located in my district at the historic Westinghouse Corporation in Cranberry Township. And what this project aims to do is to innovate in the nuclear power industry by continuing to provide carbon-free, reliable electricity through a microreactor made of advanced materials that can be modeled, and component samples can be fabricated and tested with the ultimate goal of reducing the cost and making these plants more available worldwide. I'm very pleased with the progress of this project, but I know it's expensive and difficult, and they might not be able to pursue it without the help of a program like ARPA-E. So now I look forward to the testimony of our witnesses, the opening statements of other members, to learn what else we can do to improve this great program. The chair now recognizes Mr. Weber for an opening statement.
Thank you, Mr. Chairman. Thank you all for all being here today. Today we are going to hear from our panel of experts on the status of the Department of Energy's Advanced Research Projects Agency, Energy, ARPA-E, and discuss how Congress can effectively evaluate and reform this fundamental science program. Created in 2007, as noted by the chairman, DOE's ARPA-E program was modeled after the Department of Defense's DARPA program. The agency was intended to provide finite R&D funding for innovative projects that could have disruptive impact on critical American economic, environmental, national security, and energy sector challenges. Specifically, ARPA-E was tasked by Congress to reduce reliance on foreign sources of energy and energy-related emissions, and to improve energy efficiency in all economic sectors. ARPA-E was intended to be unique among DOE's applied research programs. The agency aims to achieve its goals by funding the highest risk, highest reward fundamental science, the transformative research that industry will not pursue. But today, it's unclear if ARPA-E remains true to this inspiring mission. While there are examples of truly groundbreaking research, like the project exploring unique fusion reactor designs, there are also a large number of programs that actually overlap with DOE's applied energy offices. For example, today, ARPA-E has funding announcements or active programs supporting research in wind energy technologies, advanced nuclear technology, and energy storage systems for the electric grid. All areas of research that already receive funding through other DOE programs. Industry already has an interest in developing incremental improvements to today's energy technology. We cannot afford to spend limited federal resources on duplicative, late-stage programs that compete with private sector investment. Instead, we should refocus the ARPA-E program on its original purpose, taking fundamental science discoveries and applying them to our biggest technology challenges. This approach could provide solutions across the department's diverse mission space, including areas like nuclear waste management and national security. With the agency's unique expertise, I believe that this program is capable of supporting a new generation of scientific breakthroughs. But that won't happen without real reforms to prevent duplication and refocus ARPA-E on the greatest technology challenges. We also can't just assume that big increases in spending will magically appear in the budget. If ARPA-E's budget is increased, we will inevitably have to make tough choices and cut spending elsewhere in the department. In preparation for this hearing, I thought about what breakthrough energy technologies look like. And I was reminded how hydraulic fracturing and horizontal drilling revolutionized the global energy market. Research at our national labs laid the groundwork, and American industry picked up and harnessed those discoveries to change the world. We need to focus agencies like ARPA-E on applying DOE's basic science discoveries. With this approach, I believe that American industry can capitalize on that research and revolutionize the energy industry once again. I want to thank the chairman for holding this hearing today and the witnesses for coming in to provide your testimony, and I'm looking forward to a productive discussion about ARPA-E's future today. Mr. Chairman, I yield back.
Thank you. The chair now recognizes Chairwoman Johnson for an opening statement.
Thank you very much, and good morning to our witnesses. Thank you, Chairman Lamb, for holding this timely hearing to review the impressive performance of ARPA-E to date and to explore new ways that this vital program might accelerate America's transition to a clean energy future. About 12 years ago, since this agency was first authorized by this committee, and 10 years since it was finally funded thanks to the American Recovery and Reinvestment Act, ARPA-E now plays a critical role in maintaining America's economic competitiveness by advancing high-risk concepts that previously lacked federal or private sector support, but could have significant impacts on the ways we produce and use energy. Thus far, 71 ARPA-E projects have led to the formation of new companies. 109 have partnered with other government agencies for further development, and 136 have attracted over $2.6 billion in private sector follow-up funding. This clear record of accomplishment is why I was proud to introduce the ARPA-E Reauthorization Act in 2017 in the last Congress, which had 39 co-sponsors, including 11 Republicans. That bill was endorsed by an incredibly broad coalition of stakeholders, including the U.S. Chamber of Commerce, the National Association of Manufacturers, the American Council on Renewable Energy, the American Petroleum Institute, the Nuclear Energy Institute, the Alliance to Save Energy, the Bipartisan Policy Center, and the Energy Sciences Coalition, just to name a few. and I think we can do better this year. I was also proud to co-sponsor ARPA-E Act in 2018, introduced by then Vice Chairman Lucas, and I look forward to continuing to work with him and my colleagues on both sides of the aisle to enable this agency to be as effective as it can be in achieving its mission. Before I close, I'll note that over the last few years, this program has been the subject of several overwhelmingly positive assessments by widely respected bipartisan and nonpartisan institutions like the National Academies, the American Energy Innovation Council, and most recently by the Breakthrough Energy. And in Secretary Perry's own address to ARPA-E Energy Innovation Summit last March, he said, and I quote, "ARPA-E is one of the reasons DOE has had and is having such a profound impact on American lives." I couldn't have said it better myself, so I certainly hope that in its next budget request, this administration will reconsider its previous and fortunately doomed proposals to eliminate ARPA-E altogether. I thank you again for holding this hearing, and I look forward to the dialogue with the excellent panel of witnesses and thank them for being here. I yield back.
Thank you, Chairwoman Johnson. The chair now recognizes Ranking Member Lucas for an opening statement.
Thank you, Chairman Lamb, and I would like to congratulate you on your new position as Chairman of the Energy Subcommittee, and thank you for holding this hearing today. And I also appreciate your acknowledging former Chairman Gordon in attendance with us today. I've had the privilege of serving with 5 of the previous chairmen whose portraits are on this wall, and I look forward to the inevitable day when we have the first lady portrait hanging, which is now inevitable too. That'll be a good day. That said, ARPA-E was created to help the U.S. energy sector maintain its competitive edge in developing advanced energy solutions. The program was established to jumpstart technologies that were too early stage to attract private sector investment that could have a significant impact on the energy market. In order to accomplish this, ARPA-E was given a unique management structure with the flexibility to start and stop research projects based on performance. Program managers have expedited hiring and firing authority to make sure that ARPA-E staff can adequately select and support. Today, ARPA-E supports fundamental research over a wide range of cutting-edge energy technology areas, including bioenergy, battery technology development, and advanced nuclear. But despite some fascinating areas of research, ARPA-E is not without controversy. For example, many ARPA-E programs have significant overlap with programs goals of DOE's applied energy research programs. We'll hear testimony today supporting big increases in spending for ARPA-E, but with $6 billion in annual spending already devoted to applied research elsewhere in DOE, ARPA-E and any increased spending for it is redundant if it's not refocused on more innovative research. Now that brings us to the second problem. We've heard concerns over the years that ARPA-E isn't meeting its intended goal, to fund the kind of technologies that are so pioneering they would never attract private sector investment, but instead providing funding to big companies with access to capital markets or funding research that's already succeeding in the private sector. ARPA-E is a program that can and has had tremendous impact on the development of new energy technologies. But we must address these concerns and refocus the agency on funding the most innovative research. That's why I, too, introduced a bill to reform ARPA-E in the last Congress, which passed the House with bipartisan support. This legislation expanded the mission of ARPA-E to include the full DOE mission and empowered the agency to promote science and technology-driven solutions to DOE's broader goals. My bill also included important direction to prevent the duplication of research across DOE and ensure that the limited taxpayer dollars are spent in the most transformative technologies, not in competition with the private sector. I hope that we can work together to include those reforms in any reauthorization of ARPA-E this Congress. It is our job to be good stewards of the taxpayers' resources, of course, and with the right mission goals and common sense conservative management, I believe ARPA-E's innovative approach can build on basic science and early stage research at the department. We can help fast track new technologies that will grow our economy, stabilize our environment, and maintain U.S. leadership in science and technology around the world. I want to thank our witnesses for being here today, and I look forward to a productive discussion this morning. Yield back, Mr. Chairman.
If there are members who wish to submit additional opening statements, your statements will be added to the record at this point. At this time, I would like to introduce our witnesses. First, Dr. Arun Majumdar is the J. Precourt Provostial Chair Professor at Stanford University and a faculty member of the Department of Mechanical Engineering. Dr. Majumdar was the founding director of ARPA-E from 2009 to 2012. During his time at the Department of Energy, he also served as Undersecretary for Energy. His current research explores chemical processes in clean energy technology, next-generation material science, and efforts to improve the efficiency of the electrical grid. Dr. Ellen D. Williams is a distinguished university professor in the Department of Physics at the University of Maryland. Dr. Williams was the director of ARPA-E from 2014 through the end of the Obama administration. Prior to joining DOE, she served as chief scientist to BP and founded the UMD Materials Research Science and Engineering Center. Her research currently focuses on surface physics and nanotechnology. Dr. John Wall, now retired, serves as the Chief Technology Officer for Cummins, Inc. from 2000 to 2015, where he oversaw the company's worldwide commercial engine emissions reduction activities. He does not, contrary to popular opinion, play point guard for the Washington Wizards. Dr. Wall served on the Committee on Evaluation for the 2017 National Academies Review of ARPA-E. He currently serves as a technical advisor for DOE's Joint Bioenergy Institute and as an advisor for Cyclotron Road, an energy technology incubator at the Lawrence Berkeley National Laboratory. Dr. Saul Griffith is the founder and CEO of Otherlab, a privately held research and development lab that develops clean energy, robotics and automation, and engineered textiles, among other technology areas. In its 10 years of existence, Otherlab has been the recipient of multiple ARPA-E awards. Over the course of his career, Dr. Griffith has founded several successful companies and was named a MacArthur Fellow in 2007. Mr. Mark Mills is a senior fellow at the Manhattan Institute and a faculty fellow at Northwestern University's McCormick School of Engineering and Applied Science, where he co-directs an institute on manufacturing science and innovation. He is also a strategic partner with Cottonwood Venture Partners, an energy tech venture fund, and an advisory board member of Notre Dame University's Riley Center for Science, Technology, and Values. As our witnesses know, you will each have 5 minutes for your spoken testimony. Your written testimony will be included in the record for the hearing. When you have all completed your spoken testimony, we will begin with questions. Each member will have 5 minutes to question the panels. We will start with Dr. Arun Majumdar.
I want to extend my thanks to Mr. Chairman, the ranking member, and all the members of this committee. Between 2009 and 2012, I had the honor of serving as the founding director of ARPA-E, where I recruited the first team and helped create ARPA-E's DNA that involved multiple elements. A laser focus on the mission of ARPA-E that Congress laid out, recruiting top talent in science and engineering using the special hiring authority that Congress provided, creating a culture internally of an open debate and discussion to unleash this talent, to fund research on the most profound breakthrough technologies, creating a model internally of operational efficiency, active program management, and financial integrity, and finally, an exemplar of engaging stakeholders via the ARPA-E Energy Innovation Summit, as well as creating a model of partnership with Congress. Because of these elements, due to the remarkable breadth of new research that ARPA-E funded, it certainly caught the attention of many thought leaders in the United States. In 2012, at the summit, the founder, chairman, and CEO of FedEx, Mr. Fred Smith, said, quote, pound for pound, dollar for dollar, activity for activity, it is hard to find a thing the United States has done that is more effective than ARPA-E. Bill Gates and his colleagues had very similar comments as well. Given all this, I'm going to address two questions in my opening remarks. Number one, what is the key to ARPA-E's success that needs to be preserved? Number two, what else can ARPA-E do to make the U.S. even more successful and globally competitive? As you know, ARPA-E is modeled after DARPA that has an illustrious 60-year history. Like DARPA, ARPA-E defines the cutting edge of science and engineering research for breakthrough technologies that will form the foundation of entirely new industries that do not exist today and make the U.S. industries more competitive in the world. But to achieve this, it is critical to have the most talented people within ARPA-E, ones who are at the cutting edge of creative research in science and engineering. It takes one to be at the cutting edge to recognize what is cutting edge. So in many ways, ARPA-E is all about the people. As the director, I spend a large fraction of my time recruiting talent. None of these recruits needed a job. They joined ARPA-E to serve the nation and be part of something special. After 3 to 4 years, they went back to the private sector or academia with their ARPA-E record as a badge of honor. During the time of ARPA-E, they conceived some of the most impactful and research programs that bridged 2 or 3 different fields of science and engineering to create something completely new that no one in the world had ever imagined. So my message is the following. It is very important to preserve the special hiring authority that Congress has bestowed on ARPA-E to ensure that the leadership in ARPA-E uses this authority to recruit top talent. It is also important that ARPA-E maintain its independence within the Department of Energy and the director report directly to the Secretary of Energy. Finally, one of the best things about ARPA-E's model is that the program directors stay for 3 to 4 years, and then they're required to leave. This time constraint puts a level of urgency to make a difference, and this urgency is very important to create the internal efficiency within ARPA-E. This needs to be preserved as well. Now, my second question, what else can ARPA-E do to make the U.S. more successful? I have 2 recommendations. In the last 10 years, a lot has changed in the global energy landscape. As was pointed out, there were 3 game changers that has happened: unconventional oil and gas, revolution due to fracking, electrification of transportation via lithium-ion batteries, and carbon-free electricity generation from wind and solar. While these are necessary, these are certainly not sufficient to help address the ARPA-E mission. Fossil fuels still comprise 80% of the global energy use. The scale is simply enormous. Reducing greenhouse gas emissions, which is part of ARPA-E's mission, is a billion-ton scale problem. And to go from a lab-scale concept, proof of concept that ARPA-E funds, to the billion-ton scale solution is a long and arduous process. So the 2 important recommendations is, it is important for Congress to be patient in its expectations of commercial impact from ARPA-E-funded research. Expectation of short-term success will produce incremental thinking within ARPA-E, and that will defeat the whole purpose of ARPA-E, which should be going for the home runs. Secondly, it is also very important to look at the gaps beyond ARPA-E funding and to see what has worked in the past, to see if you could create private-public partnerships to enable some of these proof of concept that has been proven in the labs, in universities and national labs, to go eventually make this journey to the private sector. Thank you for your time, and I appreciate the opportunity.
Dr. Williams?
Thank you, Chairman Lamb, Ranking Member Weber, and other members of the committee. I truly appreciate the opportunity to appear before you today to testify on the future of ARPA-E. I was the 2nd director of ARPA-E, and I benefited from the innovations and the activity that Professor Majumdar has just described to you. I would like to say that ARPA-E is an innovation agency, and one set of words you never hear in ARPA-E is because that's the way we've always done it before. ARPA-E uses innovation in its thinking, in its development, and in its planning. As director of ARPA-E, I frequently consulted the agency's founding authorization, which I consider to be just brilliant. It recognizes the importance of technological innovation in the world's evolving energy systems and the implications for the United States of the international competition in advanced energy technologies. A goal called out in the authorization is for the U.S. to remain a leader in advanced energy technologies, and based on our capabilities, we should certainly be able to do so. However, even though the United States has been a world leader in basic research for most of the last century, our country has been notably less successful in transferring the benefits of its basic research successes into domestic manufacturing and the economic benefits that follow. ARPA-E is tasked to address that problem by translating cutting-edge discoveries into technical innovations. To do this, ARPA-E has developed a transformative research management model in which brilliant innovators, like Saul, are supported and mentored to advance both the technical performance and the commercial potential of their innovations. This process is essential for drawing value from early cutting-edge technologies that the private sector will not support because they are considered too risky. We've heard about ARPA-E's measures of successes, and we've heard that there have been many recommendations to increase the level of fundings for ARPA-E. I believe you'll hear some of the stories of actual technologies and the teams that make them successful from Dr. Griffith, and Professor Majumdar and I would also be happy to provide more examples. I would say that each year, ARPA-E sees far more opportunities flowing from the ingenuity of America's scientists and engineers than it has the ability to support. Many experienced observers, such as the American Innovation Council, have called for substantial increases in the agency's budget. I agree with that assessment, and I agree that it needs to be addressed in an innovative and creative fashion, not just more of the same, but really addressing new challenges in new ways. In creating strategies for growth at ARPA-E, as we thought about mechanisms for increasing the budget and using the budget effectively, we looked for opportunities to yield even greater impacts per dollar for the U.S. economy and identified 3 approaches. The first approach is to address the problem that at present, even the most successful ARPA-E projects are still often judged too high risk by potential investors. As a result, they struggle to obtain early investments or may be undercapitalized compared with their international competitors. ARPA-E could give such companies a faster start with expanded programs for innovative scaling and advanced manufacturing processes suitable for domestic manufacturing. These would not be incremental improvements. These would be looking for game-changing improvements in how we do manufacturing and how we bring technology to commercialization. The programs would support the most competitive projects to move from the stage of successful prototype to pilot-scale demonstrations. The expanded effort would work collaboratively in terms of drawing funding and increased investment opportunities in the United States and prevent innovative U.S. companies from being stranded or frozen out of markets by international competitors who can move more quickly. The second approach is to expand investment in the earliest stage, most innovation, and thus highest risk technologies. These represent the pipeline of innovation for the future. ARPA-E's open program funding opportunity announcements, which allow proposals at all areas of technologies, are an important discovery mechanism and have given rise to exciting new technologies such as SLIPs, incredibly low friction surfaces, sky cooling, materials that spontaneously cool by sending heat into outer space, and 4.0 technology, which uses laser power for drilling in hard rock. Finally, ARPA-E can expand its core focus programs to include more larger scale technologies and integrate performance demonstrations and prototype to pilot funding to optimize handoff to commercial development. The vision of the future of ARPA-E requires changes, but that's appropriate for an innovation agency, and it's already enabled by the flexibility built into its authorization. An expanded budget for ARPA-E will enable more early-stage, cutting-edge technologies to be moved more quickly and more effectively to hand off for private sector commercialization in the U.S., boosting U.S. competitiveness and economic growth. Thank you again for this opportunity to speak.
Thank you, Dr. Williams. Dr. Wall?
Chair Lamb, Ranking Member Weber, Chair Johnson, and Ranking Member Lucas, and other distinguished members of the subcommittee, thank you for the opportunity to testify about ARPA-E. My testimony today is guided by my career working on energy and environmental technologies at Chevron and Cummins, a Fortune 200 engine and power system manufacturer, and as a member of the National Academy of Engineering on a recent National Academy study to assess the first 6 years of ARPA-E. I'd like to make 3 main points today. ARPA-E plays a vital role in U.S. energy innovation beyond what industry can do for itself. ARPA-E's unique use of experienced practitioners as program managers is important for its success, and ARPA-E is critical for U.S. global competitiveness. First, ARPA-E plays a unique and vital role in U.S. energy innovation beyond what industry can do for itself. Innovation in industry happens, in energy happens across a broad spectrum, from novel, unproven hypotheses to integration into products that are then bought and used by customers. Innovation only has value if it makes it all the way into use. Required investments grow through this progression from thousands to millions to hundreds of millions of dollars. De-risking of novel concepts is a very important element of this development process to allow for rational business investment in product development and productionized manufacturing. A manufacturing company is not equipped to do all the research required for breakthrough and disruptive innovation internally. In fact, they may not even recognize it when it's happening, but they can embrace it, scale it up, and bring it to market once it's validated. For example, this year Cummins is celebrating its 100th year in the diesel engine business and also is introducing its first all-electric powertrain. While Cummins was innovating in the diesel engine space, those electric powertrain technologies were being developed and validated independently by innovators with unique skills that Cummins simply did not possess. But they've now been brought into the company for integration into a new product line. ARPA-E facilitates technology development and transfer like this, with culture and talent specifically aimed at identifying promising concepts in critical energy areas and nurturing them to success. The National Academies found that one of ARPA-E's strengths is its focus on funding high-risk, potentially transformative technologies, and ARPA-E has funded research that no other funder was supporting at the time, technologies which are now beginning to enter the commercial market. But it's not just about funding. ARPA-E attracts experienced practitioners into relatively short-term government service with the specialized skills to evaluate new technology concepts and to manage them forward. Empowered program managers are a unique and critical component of ARPA-E's success. They're accorded wide latitude in identifying research themes, creating new programs, supervising projects, identifying commercial opportunities, and when necessary, terminating projects through very active program management. So this is not casting our bread on the water, it's cultivating fish. My final point is that ARPA-E is critical to U.S. global competitiveness. Energy is a multi-trillion-dollar industry. It provides jobs and security for our citizens. It is undergoing a global transformation from traditional energy sources to new generation, power, and storage technologies. And other governments get it. Consider Cummins' experience in China. Cummins entered the Chinese engine market very successfully based on world-class emission technology that far exceeded indigenous capability, and later moved on to a hybrid powertrain partnership with China government support. That support was abruptly terminated as China realized that the rest of the world was ahead in that domain too, and shifted to a focus on battery electric vehicle powertrains with their strategic intent to lead the world in EV production. As I was reflecting on this, I looked up the current China 5-year plan. Here's some of what I found. Ensure innovation in science and technology takes a leading role. Encourage public startups and innovations. Develop strategic emerging industries. Build a modern energy system. Make no mistake about it, we're in a race without a finish line, and it is a global race. ARPA-E's unique mission, structure, active program management, and drive from innovation into commercialization are critical for American technology leadership, for American business leadership, and for American jobs, especially high-tech jobs. That's worth $1 billion investment in ARPA-E and secure year-over-year funding. I ask that my full testimony and the executive summary of the National Academies 2017 report and assessment of ARPA-E be submitted to the record, and I encourage the committee and subcommittee and staff to read the full report. Thank you very much. I look forward to your questions.
Thank you, Dr. Wall, and I can assure you we will. Dr. Griffith, please.
Good morning, and thanks everyone for giving me the opportunity to talk about my favorite topic, energy innovation. I moved to the US in 1998 to do my PhD at MIT, and after completing that I moved to Silicon Valley in 2004 to be at the heart of the technology industry in this country. We created Otherlab, is a small independent research lab created to make technologies that are commercializable, and we commercialize them by spinning companies out of Otherlab that grow themselves into standalone viable entities. I guess I'm here to give case studies of successful ARPA-E projects. I founded a company, a wind energy company called Makani Power in 2006. The idea was to build wings the size of 747s and fly them on a string about a mile above the ground in flying in circles at 200 miles per hour and generating electricity from them. In 2009, we got ARPA-E funding, $3 million, and I can say with certainty that Makani Power would not have existed were it not for that investment. Makani Power then got acquired by Google, and under Google X, about $100 million more was invested in that company. They are now generating net positive power, and just this year have announced a partnership with Shell, one of the world's largest energy companies, to do offshore deployments of what is fundamentally a transformational new energy technology. In 2012, we started another company called Sunfolding. The sun moves across the sky. Sunfolding is a very simple idea. How do you track the solar panels as the sun moves across the sky? You get about 25% more energy by doing so. Traditionally, this is done with complicated machines and expensive little electric motors, gearboxes, and mechanical components. We had a radical idea to move those with plastic bags. That turns out is a crazy idea, but it works. We got 3 different rounds of funding from ARPA-E to make that technology work. We tried to get investment in that technology prior to ARPA-E funding. Nobody would believe that it was going to work. That is so successful that we are now producing 10 or 20 megawatts a week of these trackers. We're manufacturing in 6 states across the US. We're employing 25 people. We'll be doing a C round of funding for that company this year. And it looks like being the next success story in the solar industry. Other examples, we started, there was a MOVE program, Methane Opportunities for Vehicular Energy in 2012. ARPA-E wanted...
Don't worry about that.
I'm in Washington, I worry about those sounds. ARPA-E wanted to support the natural gas industry with technologies to run vehicles on natural gas that would make them lower carbon per mile. One of the problems, however, with natural gas vehicles is the big spherical tank that doesn't fit very well in the back of the truck or in the trunk of the vehicle. So they wanted to make what's called a conformable gas tank. Make a gas tank that can fit in the nooks and the crannies of the vehicle so that you can get more natural gas in there and make the cars go faster. We used some arcane mathematics to come up with a new idea. Basically, imagine that instead of one big tank, we made a giant intestine of a tank. This reduced the cost of making tanks by about 20%, the weight by about 20%, increased the range of those tanks by 30 to 40%. That technology has been licensed into the natural gas industry and is being commercialized in partnership with Westport. That technology was then further developed with funding from many different automotives. So we got about $10 million in development revenue from the major automotives to also develop the same technology for hydrogen vehicles, and that hydrogen technology has now been licensed to Linamar, a major OEM, and is going to market in that industry. Another radical idea we had was to make clothing that could change its shape in response to temperature. The idea being if it gets cooler, the clothing gets warmer. If it gets warmer, the clothing gets cooler. I did that in partnership with a colleague from MIT who had originally come to work on sunfolding as our material science. But the one point to emphasize here is that ARPA-E is funding a community of people, and they get funded on one project and they often go on to work on other energy technologies. And that community is fundamental to the value of ARPA-E. We've been able to use that ARPA-E funding to develop entirely new manufacturing processes, knitting and weaving processes to create this textile. We've secured so far about $2.5 million in venture funding. That company will probably be deploying that technology in real products, bedding and clothing next year, and we'll be doing another fundraise this year. We did another program called the Super Sankey. This was not focused so much on making an energy technology, but rather, how do we understand the US energy economy in the greatest possible detail? So we pored over all existing government sources of data and some non-government sources of data to build the most comprehensive flow diagram of all the nuanced relationships in the US energy economy. And this tool is now online. And in fact, in their last ARPA-E's last open FOA, they suggested that teams use this tool to understand the potential impact of their technologies on the US energy economy. It also highlighted that there are great opportunities for re-examining how we gather data about the US energy economy and how we report it in order to support how we transition to a new energy economy.
All right, thank you, Dr. Griffith. We'll stop you there at the end of the 5 minutes and move on to Mr. Mills.
Good morning. Thank you, Mr. Chairman and members of the committee, for the opportunity to testify here. I'm honored and, in fact, humbled to join such an esteemed team of witnesses and join in enthusiasms for ARPA-E. It's one of the rare opportunities for true bipartisan enthusiasm. In that context, I'd like to use my 5 minutes to frame the ARPA-E transformational mission by talking about the energy scale challenge. I mean, traditional metrics are really inadequate for visualizing the magnitude of the global oil, coal, and natural gas production. Other witnesses have pointed out that 85% of the world's energy comes from hydrocarbons, but if they were all in the form of oil and laid out in physical barrels, that would form a row stretching from Washington, D.C. to Los Angeles, and that row would grow in height by a Washington monument every single week. Then, as the world's poorest 4 billion increased their energy use to just 15% of the per capita level that we enjoy in the West, the world's demand for energy will increase by the equivalent of adding the United States worth of demand. And in the developed countries, we can consider the implications in the future of just two fast-growing sectors. Every $1 billion spent on in commercial aircraft or $1 billion spent on data centers each leads to about $2 billion in energy purchases over a decade. And the world currently spends over $100 billion a year building and supplying to markets new airplanes and data centers. Meanwhile, we do know something about the cost of policies to impact this enormous market. Over the past 2 decades, the world has spent more than $2 trillion on non-hydrocarbon energy, but hydrocarbon use rose nearly 150% over that time, and hydrocarbon's share of global energy supply decreased by barely a few percentage points. This scale challenge, of course, commonly elicits the aspirational proposition that we should embrace the spirit of the Apollo program. The problem is this analogy is that it's a category error. Transforming the energy economy is not like putting a dozen people on the moon a handful of times. It's like putting all of humanity on the moon permanently. But in the decades since the Apollo program, we've seen another and bigger tech revolution that's inspired a similar trope. This is, of course, the computing communications revolution, often short-formed as Moore's Law. The International Monetary Fund, to just pick on one example, has asserted that, and I quote, "Smartphone substitution seemed no more imminent in the early 2000s than large-scale energy substitution seems today," end quote. But the Moore's Law transformation in how energy is produced or stored isn't just unlikely. It can't happen with the physics that we know today. If photovoltaics scaled like computing, a postage stamp-sized solar array could power the Empire State Building. Similarly, if batteries scaled like computing, a book-sized battery that costs 3 cents would fly an A380 to Asia. Only in comic books does that physics of energy production work like that. Of course, wind turbines, solar cells, batteries, all those will improve. So too will drilling rigs and combustion turbines. And of course, software will bring very important and even dramatic efficiency gains. But there's no possibility that more federal funding will lead to digital-like disruptive tenfold gains in these old technologies. All are approaching their physics limits. The relevance of ARPA-E is that its out-of-the-box mission can only come from new phenomenologies, and that lead eventually then to radically new technologies, all of which can only come from basic research. To state the obvious, the internet didn't emerge from improving the rotary phone, the transistor didn't come from subsidizing vacuum tubes, and the car didn't come from studying railroads. Policies in pursuit of an energy revolution require a focus on basic science. One example in an area which is seeing a deficit of research support, where I think magic can yet happen, is in the basic material sciences. Let me conclude by summarizing 3 things Congress could do in order to fulfill the mission originally envisioned for ARPA-E. All 3 are found, in fact, in the original Gathering Storm report. First, ARPA-E should ensure a very clear focus on basic science. A vital role for ARPA-E is in filling the often ignored gap between a foundational science discovery and validating whether that radical new discovery is in fact useful. This is quite different from the often cited gap between innovation and commercialization. Second, Congress should, I think, put ARPA-E's role under the Undersecretary of Science as originally envisioned to both signal a commitment to basic research and insulate it from what I would call contamination of near-term outcomes. Finally, ARPA-E's budget, I agree, should increase, but I would also stipulate as a caveat that we should adhere to the Academy's original recommendation, funding those funds by reallocating from those federal programs that are already doing what I would call de facto private sector development. Finally, I think Congress should follow the Academy's proposal to continue to review the performance of ARPA-E, but in particular this time with an independent committee that it's not dominated but includes federal representatives so that the private markets that understand basic science transitions participate. I have no doubt that scientists will yet unveil what Bill Gates calls an energy miracle. That's the word Bill Gates used, but that won't come from spending more money on yesterday's technologies. Thank you.
Thank you, Mr. Mills. At this point, we'll begin our first round of questions, and I will recognize myself for 5 minutes. First, I want to talk about how we track the success of ARPA-E over time, and I think Dr. Majumdar and Dr. Williams, you both kind of addressed this in your testimony. I'll start with Dr. Majumdar. What do you think about the idea of this metric of the amount spent by the federal government on ARPA-E versus the follow-on private funding that has resulted from it? Recognizing those two don't match up exactly because the private funding only attracted to a small percentage of what was funded in the first place, but do you consider that to be a decent measure of progress for ARPA-E?
Well, thank you, Mr. Chairman. I think this is a really important question. I was asked this question, believe it or not, in my confirmation hearing for being the ARPA-E director by Senator Murkowski, and we spent a lot of time thinking about it. The question is, how do you define success? And one can think of success as a full commercial scale like the internet today. And just taking the example of internet, the research in computer networks started in 1968. It took 25 plus years to really get full commercial impact of the internet, and during that time it was funded by DARPA to really improve and fine-tune that thing. So looking at ARPA-E's technology, ARPA is funding mostly proof of concept ideas. To take proof of concept and go all the way to commercial scale is, as I mentioned, is a long process. It takes 15 to 20 years. So the only thing we can really say post-ARPA-E right now is, what are the signs or metrics of future success that we should be looking for? And I think there are many of them. There's not one single, there's no silver bullet in this one. I think one should be looking at, is there intellectual property creation that has happened? Is there follow-on private sector investments and on ARPA-E related projects that are showing some signs of success?
And I agree with you there, not to cut you off, but time is limited, so thank you. And Dr. Williams, you did specifically cite that figure of the follow-on private investment. So I know it's tough because of the time scale that you all are talking about. Something could take 15 to 20 years to commercialize. But do you still think us tracking that comparison over time is a useful measure of success, even if it's not the only one?
I absolutely believe it is a useful measure of success. It's an early stage measure. As Professor Majumdar says, it's something we can measure, and it is indicative of future success. As time goes on, you will see our ability to measure more metrics, such as jobs creation and manufacturing, but that's a longer-term process. And the scale problem that we heard about is acute. This will not happen overnight, but the cumulative impact of these types of investments and these early metrics are very, very useful for predicting that.
Great, thank you very much. Dr. Wall, go ahead.
Just a quick comment and a watch out. I think as we discovered as we were doing our Academy study that there's an inherent tension between the 3-year funding cycle in ARPA-E, people wanting to see success, and the longer-term nature of the investment. So the watch out here is that as we want ARPA-E to be really focusing on long-term benefits, that we don't put so much pressure on showing early success that we wind up shortening the cycle and then turning it into some of the issues that have been raised about that starting to look like more short-term research.
Absolutely, thank you. Mr. Mills, I just wanted to ask one question of you before I close. I take your point about the tension between the basic science research and some of the other proposed ideas for ARPA-E. I guess one concern that I have is that this isn't happening in the vacuum of the United States. We have foreign competitors, especially China, who will really stop at nothing to dominate certain industries. They're very open about that, actually, and there was the great example from Dr. Wall about what happened with electric vehicles. So they have no hesitation about putting a lot of money into the commercialization of existing technologies. Given that competition that we face, do you think there's still a role for the commercialization funding as a way of accelerating what might otherwise happen through the private market to keep us competitive?
The short answer is yes, there is a role, but this is always a challenge that you have in Congress is the where you lie in the spectrum of the nature of that role. I'll give as one example. When as you know, I worked in the science office in the Reagan White House, which dates me as not being young anymore. The Congress and the White House was lobbied heavily then to mount a program to counter the Japanese program mounted by MITI for next generation computing. We were told then that the Japanese were going to take over the computing business and leapfrog IBM, which dominated world markets then. The approach of the science office then was that we like to support the commercialization of next generation technologies, but the president did not believe that anyone in government actually knew specifically what to commercialize. And that was the same year, by the way, that Steve Jobs took Apple public and was not one of the companies that was on the radar of changing the computing world. So I think this is the tension, but also the temptation is to fund what we think will be the revolution against the huge funding by our competitors, then Japan, today China.
Thank you very much. That's a helpful example. And I now recognize Mr. Weber for 5 minutes.
Actually, I'm going to yield to Mr. Norman for 5 minutes.
Thank you, Congressman Weber. I appreciate you yielding. Mr. Mills, this will be directed to you. I'm from the private sector. We look at results, not intentions. We look at results. And let me just read some of the numbers. As of February 2018, the program has invested approximately $1.8 billion in R&D, which funded over 660 projects through more than 44 programs. And in your testimony, you mentioned the need for audits. Do you think these audits would be useful in highlighting duplicative programs, overlapping, so that we can track where the dollars are yielding results?
Well, thank you for the question. I'm deeply conflicted in this area because I've written about, and in an early life I was a research scientist. I'm extremely enthusiastic about the prospect for government giving more money to scientists. At the same time, I work in the private sector, and I'm very sensitive to results, outcomes. My proposal for an audit is really focused on two things, not just looking for duplication, which there's some merit in duplication. I mean, we do this in the private sector, as you know. You might have two teams trying to solve a problem orthogonally, but there can be too much duplication. What I would like ARPA-E to focus on is avoiding doing work that doesn't adhere to its mission. There are missions for basic development, but the underlying transformational science mission, I think there's a potential, looking at some of the programs, that is a drift towards doing things that are, in fact, the missions of other agencies in the Department of Energy. They're really not transformational. So the other part I would like to add just briefly is that the holding ARPA-E to a utility function that can be specifically measured like dollars and patents is a natural tendency, but I think it's a mistake. I think it's useful, but it will not measure transformations. And I think it's not trivial. There's no easy measurement. I think the witnesses have pointed this out. And I think if you were in a confirmation hearing, you would be forced to say, what's my measure? I understand that. I think there would be merit to forming a committee as part of ARPA-E's future look to come up with an additional creative answer to that question. What else could we use that would help us understand that what ARPA-E's funding has the potential to be transformational, not simply evolutionary to making a PV cell better? That's important, but that would be a private sector mission in my view.
Do you think it would be beneficial to put it under the Department of Energy?
The ARPA-E or the?
Correct.
Sorry. Well, I think it's got a good home. I think the challenge is a version of being insulated from the near-term. If you report to the Secretary, it's a better status. I understand that. But the Secretary is driven by the budget near-term mission. One would hope that you create an entity that has some of the insulation that an SEC might have. Some of the agencies that can operate on 5-year cycles where the chairman or the head of it isn't turfed out for failing on a budget metric, but rather they have a different mission. The SEC doesn't have a budget mission, for example. It has a broader social and regulatory mission. In my view, ARPA-E is more in that category than it is a traditional research category.
Dr. Griffin, did you want to say something?
Absolutely. Your concern, I believe, was that ARPA-E's funding may be duplicative of other agencies.
Well, I don't know that. I'm saying why not put a measure in place that could see for the benefit of the program to see if...
I might respectfully suggest that it's not terribly relevant. We applied for, I have now created and commercialized technologies that would not have existed without ARPA-E. We tried to have those things funded through the other agencies of the Department of Energy, and they were non-receptive because, in general, those agencies are more prescriptive about what they're looking for. So ARPA-E's beauty is that it has very wide purview on what is transformational, and so it can pick and choose, and I think it is doing a very good job. So I think it almost by necessity needs to be duplicative in the sense that there's solar here and there's solar there, because the transformative is in the details, and in how ARPA-E has a wider mandate to fund a broader array of entities. For example, ARPA-E can fund a small startup company like mine that doesn't look like a national lab, doesn't look like MIT or Stanford, and don't believe that they're the only places that ideas in this country come from. In fact, in Nature, they just showed that small teams operating independently are the biggest force for transformational R&D in the world. That looks like small companies like mine that, quite frankly, aren't allowed to access a lot of the other funding within the DOE. So ARPA-E is really the only option.
Thank you for your testimony.
Chair now recognizes Mr. Lipinski for 5 minutes.
Thank you, Mr. Chairman. Thank you for holding this really important hearing. It's great that Chairman Gordon is here. I remember working. I think I'm the only one up here who was here when we established ARPA-E. I think that I wish that there were more chairs that were filled here, because there's a lot of talk right now about climate change and what should be done. There's a lot of talk in politics, social media, about some other, vague, big, broad ideas. But this right here, ARPA-E, may be the most important thing we do on climate change this year if we put more funding into ARPA-E. I was just talking to Bob Inglis, who used to sit on this committee. He's, been dedicated over the last 10 years to getting a carbon fee put in place. It's something that I support. But here's something I think we all should be able definitely to support, is more funding for ARPA-E. It was envisioned to be funded at $1 billion annually, not $1 trillion, $1 billion annually. Fiscal year 19, it's at $366 million. So I wanted to ask, what do you think would be the difference if we could get that funding for fiscal year 20 up to $1 billion? What difference will that make in it, really advancing these, green energy technologies? So, Dr. Majumdar, do you want to begin?
Thank you, Mr. Congressman. I think, first of all, I appreciate your support of ARPA-E right from the beginning. I think the $1 billion budget, there's a lot of discussion on that going on. And if you look at internally within ARPA-E, what fraction of these amazing ideas that come in as proposals to programs, what fraction gets funded? In a regular program that is announced in a funding option announcement, and if you go through the whole screening process, it's only about 10% or 15% of the actual proposal get funded. The next 10 to 20% are equally good ideas. We just run out of funding. If you look at open funding opportunity announcement, and there's a lot of discussion on the rest of the Department of Energy, there's no one in the Department of Energy that actually has an open funding opportunity announcement, open for any ideas. And in those open FOAs, the rate of success for proposals is less than 5%. And so there's a tremendous appetite for innovation in the United States that is not being funded. In fact, in the Energy Innovation Summit, on the recommendation of former Chairman Gordon and others, we actually invited the people we could not fund because we wanted them to get funded as well from other sources because these were really, really good ideas. So there's a tremendous opportunity to build the ecosystem and the community, the energy innovation community, to be much larger as is needed to address the major challenges that we have.
Let me move on to Dr. Griffith. I'm sorry I have limited amount of time here. I know Dr. Griffith had a hand up.
I exist at the coalface, or maybe I should say I exist at the solar cell of this issue. I haven't had to really place a job ad to hire people for the last decade. I have volumes, probably 10 of the best and brightest young Americans who've been trained by the best universities in the world volunteer themselves to me every week. We want to work on energy technologies. We want to work on climate change. We want to come and work for you. We have our own ideas. Without doubt, there is at least tenfold the good ideas that are currently being funded under ARPA-E existing in the minds of your young people. And you want to get the money as directly as possible to the 25-year-olds, not their professors. The professors are working on last year's technology. You've got to get it to the grad students who are imagining next year. ARPA-E can do that. I would argue that it should have funding that looks more like DARPA, $3 billion a year as a budget.
And I want to move, don't have much time, but Mr. Mills raised an interesting argument there that we need transformational, not evolutionary. I think Dr. Williams wanted to respond on that. Just want to see what your thoughts were on that.
Yeah, so very much the case that ARPA-E does not want to do evolutionary research and does not fund evolutionary research. Every project is selected for its potential to be a game changer, to move outside of the normal boundaries of industry roadmaps or long-term planning and things that are already mapped out and being done by the Department of Energy. So as an example of something that is that ARPA-E is working on right now, even though it is a project within the broad sphere of wind, it is a project to transform how we think about designing and developing wind technologies using machine learning and engineering technology to develop better methods of designing and deploying and manufacturing wind turbines. So that if that succeeds, it will be a completely transformational approach in an old technology. And that's the type of projects that ARPA-E can do more of and should do more of.
I see my time is up, so I'll yield back.
And I now recognize Mr. Weber for 5 minutes.
Thank you, Mr. Chairman. Excuse me. Very interesting. Mr. Mills, in your prepared testimony, well, you said a couple things about patents, for example, and I like that because not all patents yield results. I'm reminded Thomas Davenport had a patent on the electric motor in 1837 that went absolutely nowhere, and so while it was transformative, it wasn't practical. You also say that transforming the energy economy is not like putting a dozen people on the moon a handful of times. It's like putting all of humanity on the moon permanently. And quite frankly, I've got some friends that I wouldn't mind doing that with. Let me just say that and get that out of the way. But to do the latter would require science and engineering that doesn't exist today, is what you said in your statement. And we're talking about raising the funding to $3 billion, which would necessitate that we cut from somewhere else. We have to find that money. So I don't know that it is practical. Could you expand on this comment and detail the science and engineering capabilities that would be required for success in a non-carbon energy economy moonshot today? I'd like to hear you elaborate on that.
Well, first, if I might, because it's part of the elaboration, I'm in agreement with probably 99% of what's said in this hearing with other witnesses. It's one of these areas that's a challenge because the debates that are important are in the 1% disagreements, it's where the transformations happen. And my concern is in the implementation, and then as it relates to the vision, to your point, that it won't be a single magical thing. I mean, the magical thing we need to change the world's energy economy would be the equivalent of the discovery of fission, or to use a material science example, if one were able to engineer a metamaterial that was strong enough and and it was lightweight, that was a shield against X-rays and gamma rays, you could make what engineers thought you could do in 1950, a nuclear-powered car. I mean, you'd make a little pellet-sized reactor, and this would be magical. It's not crazy to think of those things, and it's certainly not possible with anything we know today. That kind of transformation would certainly be the equivalent of the discovery of petroleum or the photovoltaic effect. Some things can't be done. My point really was that you can't make a photovoltaic cell more efficient than the photons that arrive at Earth, and converting them you can't convert 100% efficiency. So we know what the boundaries are. So when one looks at a proposal, one can know, without knowing anything about its merits first, whether it can be transformational. If you change the cost of something by 20% or 30%, in business that's meaningful. It's not necessarily transformational to the world, because you're chasing other things that are changing by 20 or 30%. The market that solar and wind and biofuels and batteries compete against is the hydrocarbon market. It gets better all the time too, to the benefit of everybody on the planet. So I think your point of patents is a particularly important one. Patents are a metric, and they're important. I have a few patents from my early career. They were fairly foundational ideas. One wasn't. Some are pretty sloppy patents. The patent office can be overwhelmed, as we all know if we've been applicants. But they're an important measure. They're useful. But they don't necessarily measure a foundational change unless you look at what we, as you know, not to get in the weeds, prior art. If there's no prior art, it might be foundational. That'd be one mechanism, for example, to sort of fine-tune the ARPA-E mission, is if we get a patent, is it a derivative, an incremental patent, or is it actually foundational, no prior art?
Well, thank you for that. I do need to move on to a second question for all the witnesses, running a little bit out of time here. We've heard a lot today about the need to significantly increase ARPA-E's budget as quickly as possible. But in Congress, as I mentioned, we're going to have to find that money somewhere. We're called to be good stewards. And I'm not sure that any of our my constituents would be on board with an increase of close to $700 million. That's hard to justify back home in spending at the Department of Energy. So providing this kind of funding increase for ARPA-E is almost, as I said earlier, going to require cutting somewhere. So let me put you all in the driver's seat for a minute. Where would you cut, Dr. Majumdar? I'll start with you.
Well, that's a really difficult question to answer, Mr. Congressman.
Tell me about it.
I think this is a discussion between you and Secretary Perry and the current team out there, the undersecretaries and others.
So you've not and I'm sorry to cut you off, but I'm really short on time. You've not thought through this. Don't have an exact example. Dr. Williams, I'll give you the same question.
Well, of course, one thing that can be done and is being done increasingly at the states level is more leveraging. And there are a variety of interesting new financial mechanisms for increasing leveraging and the output benefits of what we get from ARPA-E and from other programs in government. So I would strongly encourage that as one mechanism for getting more bang for bucks out of the federal funds that we do supply.
Dr. Wall?
Yeah, I think I'd go down the same path. First of all, I'm not sure that I would close the budget debate just within energy, considering the importance of energy for our future, but to look at the entire budget, which gives you a little more flexibility. But I think as we look at growing the ARPA-E budget, we ought to be also looking at other things that they could be doing, other models that could be added. Dr. Majumdar raised a parallel to Semitech, which brings in more industrial partners who can participate in a way that's a little bit different than the model that we have now. So I'd also look at changing the operating model with this incremental funding at the same time.
Okay, well, I appreciate that. I got to go on, Dr. Griffith. Finally, I'll have to be brief, please.
To tie it to your moonshot question of the previous, what does a moonshot look like? If America plays its card right and completely electrifies its economy, it'll only need half of the primary energy it needs today to supply the economy as it is. If it does that, it will be the leader of the world economy, and it will more than pay for itself.
Okay.
If you had to just very callously look, I would look at other poorly spent budgets within the Department of Energy and the Department of Defense, their research budgets.
Okay, let me stop there because I'm way over my time, and I appreciate y'all's indulgence. Thank you, Mr. Chairman.
Now recognize Ms. Stevens for 5 minutes.
Thank you, Mr. Chairman, for this important and necessary hearing, and thank you to our expert witnesses for joining us today. As a former Obama administration official who worked in the advanced manufacturing space, I couldn't think of a more timely hearing, in part because just the other week, as my colleagues and I pondered on the House floor, what should be our moonshot vision for innovation for the quarter 21st century, for the mid-21st century, we find ourselves in the room with the sign that says, where there is no vision, the people will perish. So the burden of American greatness and our industrial might must be how we define these moonshot visions, not debating the merits of funding them, but seizing hold of the opportunities to invest and win the future. We are still in the race for our innovation and what we saw in the mid-20th century as we were racing to get to the moon. We are competing against the likes of China and Western Europe, and so we know we need to continue to invest. I now today represent Michigan's 11th district, the suburbs of Detroit, the most robust automotive supply chain in the country. We are the recipients of $35 million from ARPA-E projects, largely going into electrification, electric vehicle battery development. And we've heard from other questions from this great panel. We've heard from other questions you exercising what the ARPA-E funding does for this work. I'd like to just take it a layer deeper because the headline that I find quite alarming among many alarming headlines is that China is leading the charge for lithium-ion megafactories. China is leading the charge for battery electrification. That China now has over 70 OEMs in the battery efficiency space. Where are we? So what does it mean if we fail to invest or don't increase our budget? Dr. Williams, I'd like to start with you, particularly on the automotive industry, please.
Yes. Well, it's a pleasure to hear from you. I grew up in the suburbs of Detroit, and I also experienced the health and the dynamism of the automotive industry there. In terms of electric vehicles, we do face very stiff international competition. I would say that much of the growth that we are seeing now on lithium-ion battery and battery development is using old technologies and driving down cost by better manufacturing techniques. ARPA-E has invested lightly in electric vehicle batteries only in areas where we think we can make a transformative change in the actual battery chemistry and the future, and allow us to have future batteries that will be better than the ones that we're seeing developed in China. Coming out of that research, we're seeing many innovative, exciting new battery chemistries, and I can't emphasize to this committee too much the peril that we face. We do phenomenal basic research in the United States. We train great graduate students. We send them out to do great research. ARPA-E tries hard to take some of those exciting new ideas and move them forward to prototypes. If those prototypes reach a certain stage of development and readiness, and that next stage of investment is not there, they fall dead. We lose that investment. Other countries will know about what we've done, and they will take it forward. We have to make sure that we're able to support our young innovators to not just do the innovation, but to actually deliver the benefits that come from it. And EV batteries is one area where we absolutely need to maintain that primacy.
Yeah, thank you so much. Dr. Majumdar, this reminds me of your testimony and where you talked about the return on the investment and the life cycle of the investment. And I was wondering if you could just shed a little bit more light on where Dr. Williams left off around the continuity of funding and ensuring that we don't allow new technologies to fall into the valley of death, what this means for industries like our great automotive industry, which, by the way, has said they want to see zero emissions. They want to embrace electrification. They are looking and waiting for us to continue these partnerships, to continue to invest, if not but for the government, to lay the foundation, to set the table. That's the conversation we're having here. So if you don't mind.
Sure. Thank you, Congresswoman. I think the automotive industry, as you pointed out, is trying to pivot. This is a time of extreme importance because this is a once-in-a-century colossal change that is happening to an industry that has grown in a certain way, and they're trying to pivot. We are very proud, of course, in the United States of the Gigafactory that is going to make batteries. In China, there are 2, and now I'm hearing the 3rd Gigafactory being built. So the question that comes, the fundamental question that Dr. Williams raises, that how do you go from a proof of concept to a proof of system to a proof of pilot demonstration so that it gets into the Gigafactory? And I think this is where, in my written testimony, I posed that look back at what DARPA did. When there was a challenge to the semiconductor manufacturing industry, DARPA said, okay, you have your competitors, Texas Instruments, Intel, and others, let's just come together to create something called the Sematech to nurture some of the DARPA-funded fundamental research in breakthrough technologies that then they were nurtured by the industry, and then they took those technologies and they competed in the marketplace with products and services. So I think that's a model that, the semiconductor industry is not the same as the energy industry. So we should look at these opportunities, the things that have been done in the past, and see what are the lessons learned that could be adapted to the energy field, and see what we can do in the private and public sector together.
Thank you so much. I cede back.
Thank you. And Chair now recognizes Mr. Foster for 5 minutes.
Thank you. And I guess I'd like to start out by just seconding all the praise that's been showered on ARPA-E for its achievements to date, and my gratitude to Bart Gordon for his role in initiating this. And I'd also like to emphasize that this is complementary to the role that national labs play. An example of that would be, since we're talking about batteries, the J-CSER program, where one of the main deliverables is computer models of battery chemistries that will be developed and maintained by a large team of people that has to stay around more than 3 years. So it's not a one-shot thing. This will be a national resource and I think the labs are appropriate stewards for this. But there's a real need for something like ARPA-E to fill gaps in the private sector research and development. You can sort of analyze this as why, if this is such a great idea, isn't the private sector doing it? And the reasons that occur when you ask venture capitalists, they said, well, this is too long term, that the payoff will be outside the patent window. And that's, it's a real reason for ARPA-E to exist. The second is the low probability of success. Now, you're placing some bets that are unlikely to pay off. They'll be transformative if they do, but, and that's not an attractive investment to a VC firm that has to show the fund is making money after some small span of years. The third reason that I'd like to look into a little bit is the lack of patentable intellectual property. Very often you have a great idea, and this is wonderful, it will be transformative if it works, but it's not really patentable. And very often venture capitalists won't invest in that. And I was wondering how you handle the issue of patentable IP, both in the selection of projects to decide to get behind, and also when you contemplate follow-on funding and the probability of handing off to the private sector where patentable IP will be important. Either Dr. Williams or Dr. Majumdar.
So I'll start. I would say that ARPA-E's commercialization activities strongly encourage its teams to develop patentable IP. We don't initially select on the basis of whether or not they have patents or patentable IP. As they move forward, there are certainly different models for companies. There are many types of technologies which, if they can't be patented, are kept as company proprietary secrets. ARPA-E supports our project teams in developing such technologies and respects when they need to develop that proprietary technologies and move it forward without risk of exposure. I hope that's helpful.
Yeah, Dr. Griffith.
Writing and obtaining patents is really easy, and you can do it all day. It's expensive, so you want to do it as little as possible when you're starting new technology companies. I think it's a very bad predictor of success, but it's it's easily measurable, so we use it, but it's not at all good. In the global marketplace today, and because of the dysfunctionalities of the whole patent process, your really only advantage now is speed to market. And in as much as what do patents exist for? Maybe to help you get financing. But apart from that, it's all about speed of execution. So it's the wrong thing to measure.
Yeah, so how much of this has to do with, what I view, frankly, as the sort of assault on the patent system that's happened in the last several years, led actually by Congress, the, sort of systematic weakening of patent holder rights and various reforms that have been passed?
I think it's more fundamental and structural than that. The patent system has existed long enough that it's now easily gamed.
In what sense?
The large corporations can play it very easily. They can afford to. Small companies that are doing the really innovative thing can't. And you can have cynical large corporations basically outmaneuver you. And so I think that's one example of a structural problem. We evolved through lobbying the patent system towards advantaging large companies because they could afford to, and small companies who do the innovation are disadvantaged in the patent playing field.
Well, also when they try to enforce those patents, they're characterized as trolls and so on. It's
yes.
Yeah, Dr. Mills? Or Mr.
Mr. Mills, I was one of the ones that quit graduate school, but I wasn't as successful as Bill Gates when he quit graduate school. It's a very good
quit
point.
Undergrad, if I remember properly. But
the patent issue is interesting, and I agree with Dr. Griffith that it can be gamed and often is. And I'm worried about the attack on the patent system because it's not just in the Constitution, it has real merit. But I would point out as an active venture capitalist that patents are only one measure of what you would make an investment. Frequently, it's not speed to market is critical, but there are many things one does in a technology business, and I know you know this is truth, that are what would you call process knowledge and domain knowledge that you deliberately don't patent, because once you patent them, you've told people how to do it. And it's remarkable how much of innovation lies in that area and how little really lies in the patents. So I just for the record, I think, and that's a hard one to measure, that's measuring the team, which is a challenge for ARPA-E and it's a challenge for venture capitalists.
okay, and we've had a lot of sort of discussion of transformative high payoff research, but yet Dr. Griffith's examples he gave, many of them seemed incremental. A 20% decrease in the tank weight for compressed air, or a change in the actuator mechanism for solar tracking, which it's a potentially good idea that will take over that segment of the market, but will not really transform the economics of solar power. And I was just wondering how you view, what is the payoff that you're shooting for? Something that will transform a very small sector and make an incremental improvement. Yeah, Dr. Williams.
So I would say that I wouldn't measure incremental in the sense of 20% or 10% impact on the energy. It's incremental, I consider to be a fundamental the idea of how the technology transforms the approach. So something like the pointing mechanism based on a completely different technical approach, that's a technical innovation. It is far from incremental. It really transforms the mechanism. And what we see in an innovation system is that what are initially small projects like that combine together to create a whole learning curve, which ultimately grows and blossoms and creates much bigger impacts overall. And so this comes down to some of Dr. Majumdar's comments about the need for patience. The innovations
and that's helpful. We'll probably have to stop you there, Dr. Williams, because we're past time. And we'll go to Mr. Kasten for 5 minutes.
Thank you very much. Thank you all for coming. I have to frame this by saying that this is a bit of an unfair question for Dr. Majumdar and Dr. Williams, but bear with me. I think a lot of this conversation is about metrics, and I think we really need metrics. I'm a chemical engineer and a biochemist by training. I'm an entrepreneur by career, and a couple months ago I decided to get a new job. I mention that because early on in my career we did work on biofuels and fuel cells, and it was before ARPA-E existed. I actually had colleagues who were able to get money from DARPA, and I'm thankful that my colleagues here created ARPA-E to follow that example, because you guys really have done a lot of neat stuff, and I thank you for that, and it was urgent and necessary. In the private sector, if you're any good on the entrepreneurial side, you look at the total cost, the total benefit, and then you figure out how to structure your business to get as much of the benefit and as little of the cost. In this new job I have, we tend to think about offloading cost to the private sector as being fiscally irresponsible, and I don't think that's always the case. If I'm doing the math right, ARPA-E has invested $1.8 billion, $2.6 billion a follow-on. That's pretty successful. Relative to the challenge we face in the climate, respectfully, it's a fart in a whirlwind. And so if we're going to get to a point where you have the resources to take on the challenge that we have as a society, we need to somehow get people thinking about what you do as being closer to the way that the venture capital world works, where they celebrate the unicorns, they maybe focus on the portfolio returns and do their best not to talk about the failures. Witness Solyndra, we've kind of done the opposite on the political side, where we talk about the failures, we don't talk about the portfolio, and the unicorns go on to be privatized, and we don't talk about them too much. How do we get metrics that you all can manage to and be rewarded for, that can build the political will so that people can recognize the value that we're creating here and not have it come out buried in the last freshman comment or in a science hearing about the net gain? And what are your thoughts on what those metrics might be?
Thank you, Mr. Congressman. I think this is a very fundamental question, and it has come up many times before. I think you have to look at metrics over a time scale. I have been funded by DARPA in my research career several times. I was not involved in the internet, but what we talk about for DARPA is internet, GPS, and things like that, right? It is the unicorns. Mm-hmm. So I think long term, you will get to see some of the ARPA-E technologies. You've talked about the return on, the follow-on funding. Well, this is just the start of the follow-on funding. There'll be many more later on as these technologies mature and become products and services. So I think it's important, as I mentioned in my written comments, it's important to be patient with these. But in terms of the metrics, I would look at a portfolio of metrics, not just one. Because I think if someone gets fixated on one metric, you could be misled as to the true impact in the future.
Okay, one follow-on with the bit of time I've got left. Last Congress, my colleague Congressman Lujan introduced the Impact for Energy Act, which would have established a nonprofit foundation at DOE with the private sector to raise funds, support the commercialization and development of innovative energy technologies. I'm working with Congressman Lujan on a similar vein of that would bring it forward. Dr. Majumdar, and again, and others who can comment, if I'm following right, the NIH has raised about $1 billion in total funds and supported 550 projects alongside NIH to do this on the biomedical side. Do you believe that such a venture, such a nonprofit foundation at DOE similar to the NIH could help further facilitate private follow-on dollars to leverage what we're talking about here and give you whether or not we can approve the kind of funding that's necessary to make sure that there's other sources that can?
Mr. Congressman, I think we should look at all the great examples of the past and the lessons learned from that. I think the NIH Foundation is one of them. I think Sematech is another, and there are several other private-public partnerships that have nurtured technologies through research from the government-funded stage, which is early stage, the proof of concept, to the later stages. The healthcare industry is quite different from the energy industry. The semiconductor industry is different from the energy industry as well. So I think we should take a look at all of these and really figure out what applies, how can they be adapted to the energy industry, and see if you could create public-private partnerships like the Sematech like the NIH Foundation, but maybe adapt it to the energy sector. So I think that's what I would suggest Congress consider.
Thank you, and I yield back.
Thank you, and I recognize Mr. McNerney for 5 minutes.
Well, I thank the chair. I thank the witnesses, and I apologize for missing your testimony this morning. ARPA-E is a great program, and I'm a big supporter. I want to see it continue. Dr. Williams, could you say if there exists a gap between the cutting-edge technology that ARPA-E helps foster and the DOE loan program that commercializes technology? Is there a gap there?
Yes, there certainly is a gap. The projects coming out of ARPA-E are generally at the earlier stage prototypes, just getting ready to put up their first manufacturing. At the loan program level, basically the projects that will be supported under loans have to be fully established with manufacturing and have customers already in line. So there is a big gap between those two programs.
So there's room for public-private consortia to help fill that valley of debt?
Absolutely.
Okay, well, thank you. I'm not sure which one of you would want to answer this next question, but while ARPA-E does a lot with carbon capture and sequestration, I'm also interested in carbon renewal and solar reflection technology development, because I feel it's pretty clear to me we're going to blow past the 2-degree milestone, even if we eliminate carbon emissions today. So we need to develop that technology. Can you discuss what opportunities and challenges might exist with ARPA-E in developing that kind of technology?
Yes, so ARPA-E has investigated a lot of different areas for carbon removal. I think in addition to what one might normally think of as standard approaches, such as taking CO2 from a fossil generation plant, putting it through some other chemical process to turn it into a different useful product. That's one typical approach. There are other very different and more creative approaches as well. One is learning to breed, use plant breeding to create plants that actually capture CO2 and store it permanently in the soil. That's a completely different form of carbon capture with tremendous benefits to the agricultural community, to the rangeland community, and to forestry. If we can select and breed plants that actually take CO2 out of the air, put it in the soil, it improves the soil.
So ARPA-E is a good look at. What about the albedo modification technology? Is ARPA-E a place to do that kind of research?
ARPA-E has not specifically invested in that, although we've had some interesting projects, as I mentioned earlier, in technologies that are able to take waste heat and transform it into light that gets sent out into outer space. That's a little different than albedo modification, though.
Yes, Dr. Griffith.
I think when you're talking about carbon removal, you have to think about what material flows humanity has that are as big as our carbon emissions problem in tonnage. And basically, the only materials that we move in the same quantities are cement and food. So the big opportunities are in putting the carbon into cement or putting it back into the soil or putting it into wood products. And I think there is an enormous opportunity for fundamental material science and applied material science in those domains, and it would be very high value.
Thank you. So what types of programs would ARPA-E expand into if the appropriations were expanded? Whoever cares to answer that. What areas are ripe for ARPA-E to move into?
Well, I think there are plenty of them. If you're really looking at the carbon emissions challenge, how about really looking at very low cost, at 1/10 the cost of lithium-ion batteries to store electricity for the grid. New ways of fission and fusion reactors that will enable carbon-free electricity. Producing hydrogen lower than the cost that you can produce from shale gas. If you could do that, that'll be transformative for the oil and gas and the agricultural industry. Reimagining how to make concrete and steel with very low carbon emissions. So I can go on and on. Decarbonizing the food industry and the agriculture sector and helping and using agriculture, as Dr. Williams pointed out, to store carbon in the soil. And there are several others you can go on. What we're really talking about is a remake of a large fraction of our economy that is tens of trillions of dollars. And that's the global competition. This is the electricity, the automobiles, the steel, concrete, oil, gas, food, agriculture, et cetera. This is why other countries like China, as Dr. Wall and others pointing out, are looking at this opportunity of the world transitioning to a new energy economy. And this is why it is so important to invest in ARPA-E right now, because this time of pivot is where the transitions happen, and we need to be in this game right now.
Thanks. I'm glad I asked that question. I yield back.
Thank you, and recognize now Mr. Byer for 5 minutes.
Mr. Chairman, thank you very much. I'm sure this has already been done because I'm a late arrival, but I'd like to recognize the presence of my friend, the former chairman of the Science, Space, and Technology Committee, Mr. Gordon, and just say that he's better looking in picture than his portrait here on the wall. That's, Dr. Williams, you know, the president requested $3.5 billion for DARPA, and Congress appropriated roughly $2.5 billion for DARPA, and the president requested $0 for ARPA-E. Congress did $366 million. And I noticed that in your leadership, it got to $1 billion over that 5-year period. Do you have a sense of where it should be right now in terms of its return on investment and it's good for our society? Is $1 billion the right target number for us in Congress looking to appropriate?
I think $1 billion is a good target. I would say that rationally one could grow to that $1 billion over a period of several years, probably 5 or a little bit more years to grow to that level of $1 billion. In that growth, I expect ARPA-E would innovate, develop new approaches, demonstrate new ways of leveraging, and overall provide a whole new set of metrics and understanding about what can be delivered. So I'd say that going to $1 billion and then assessing and evaluating the success of that project would be a really excellent target for the House.
Dr. Griffith?
You have a really strong bench in this country in terms of the talent, and they're sitting on the bench, unfortunately, not playing the energy game. They're writing software to sell ads. You use DARPA as an example. It funded robotics for many, many, many years. Every single robotic company out there right now has DARPA talent funded by DARPA in the DNA of all of those companies that are doing all of the big radical transformations in robotics. I think you can easily justify a DARPA-sized budget for ARPA-E to do the same for energy. So I think $1 billion is low. It's not nearly aligned with the scale of the energy transformation challenge, and I think you have enough people and there are enough ideas and things worth working on that it would be money well spent.
You know, one of the things that we heard in this committee in years past was that the percentage of excellent rated projects submitted to the National Science Foundation and to NIH continues to decline or down in the 10% ratio, which would argue that we could allocate much more money there that would still be very well spent. Dr. Majumdar?
So given the discussion on the budget, I mean, I just want to point out, and the comparison to DARPA. So one can ask, what was DARPA's budget when it started off? So 1962 was the first appropriated budget for DARPA. It was started in 1958, but the first appropriated was 1962. And that was $246 million in 1962 dollars. And today, if you do the prorating for that, in today's dollars, it's about $2 billion. So if you are to take this energy transition seriously, as DARPA took in response to the Sputnik threat, I think that this is the level. And so what we're asking is the budget to be on the order of $1 billion, to grow, as Dr. Williams pointed out, to within a few years, not to put it suddenly. $1 billion from 300 to billion in 1 year would be difficult for it to handle. But if you could do that, I think the agency can then grow, bring in the talent, create new programs, create this public-private partnerships, and then be at the level of the DARPA impact that it ought to have.
And Dr. You were head of ARPA-E when you invented the internet too, right? I'm just kidding. But Dr. Majumdar, in your testimony, you talked about the many different, the transformation that's happening. This open, there have been a number of interesting articles in the last couple of days about the need to go to negative net carbon. Is there a better player in the U.S. economy to help us move to net negative than ARPA-E? Dr. Griffith?
If DARPA wants to get involved, that would be good.
But both, yeah. And carbon capture, how plausible is removing carbon from the air or from the ocean?
I think you need to place realistic expectations on it. It's very, very difficult. When you remove carbon from the ground and you combine it with oxygen, that's what happens when you burn it. It expands in volume a lot. So we can't stuff the carbon dioxide back into the hole it came from because it's bigger than what came out. And a free space floating molecule of carbon dioxide is very hard to capture. And thermodynamically, it's highly uncertain that's possible. I think what you should really focus the mind on is a complete commitment to electrification via nuclear, wind, solar, and renewables. The electrification of heat, that has to be done, otherwise we're going to be natural gassing our way through heat forever. And then focus on the material side of the economy where there are opportunities to do limited carbon sinking, which is concrete and cement, wood and paper and pulp industry, agriculture.
Great, thank you. Mr. Chair, yield back.
Thank you. That ends our round of questioning. I did want to, and the members that have to leave don't need to stay for this, but I did want to just first of all, thank the witnesses again for coming all this way and for the information. There were a number of you throughout the hearing that I could tell really wanted to jump in on a certain topic, and we appreciate that. So we could start in reverse order with Mr. Mills and just ask you to keep it short, but if there was sort of one small thing that you wanted to mention that you didn't get out, and don't feel obliged to take me up on this, but if there's one short thought, we'll just go down the row. Thank you.
Well, I do feel obliged. I'm sure all of my colleagues do. I'd like to just to point out that you heard a common theme, which would be the material science domains that are extraordinarily important here, and they're very difficult to justify on a venture capital basis, but they do hold the potential for magic, but they will require much more basic science support for chemists and mechanical engineers, solid-state physicists, doing things that are very, very challenging. That NIH may not, not NIH, but NSF may not do. A good role. Love to see the budget to go up. I like the DARPA level budget, but my caveat, I'd like to take it away, the hard task that you all have, from programs that are short-term focused in other areas of DOE.
Contradicting my colleague, Mr. Mills, and even contradicting Mr. Gates, you don't need a miracle technology to go to decarbonize the US economy. Everything we know today, everything that's on the table, we just need a huge commitment to it. I think you should look at ARPA-E isn't perfect, but it's better than all the other agencies. I think the fact that, like DARPA, it can look all over the US economy for the best ideas speaks to its benefit. We need more research money, R&D money that looks like that. And I think you really need to understand that at the end of the day, this type of funding is about building your team, building your bench. DARPA's investment invests in communities of people that become the intellectual communities that form the foundation of AI, the foundation of computing, the foundation of the internet, the foundation of robotics. And you need consistent long-term funding at much, much higher levels than you have today if you want to have the world-class bench in energy technology.
So being the big industry guy, I will take a little different approach to my remarks here, because I feel like, I may have a clearer picture of the global competition in business once the technologies are developed. Who manufactures it, who sells it, who has the jobs, who makes the money. And I worry a little bit that when we get into this discussion about taking money from one part of the our energy investment, putting it to another, or being focused internally on the US, we lose the fact that China's not the least bit confused about this. I've spent time over the last 20 or 30 years in Japan, in Western Europe, in India, in China. And so I'm keenly aware of what it's like to compete in those markets, and also, as I mentioned in my testimony, a specific example of what happened in China, where they've decided they want to dominate in EV. They're not having a debate about whether or not they should be working on basic research. I do think that one of the things that we could be doing with ARPA-E is looking at the enabling technologies that might be required to bring some of these into production. So advanced manufacturing, advanced materials, hand in hand with new concepts for new energy. But if the U.S. starts focusing on, do we put a dollar here or a dollar there, and taking it away from other energy investments, then I think we could be making a big mistake in setting ourselves back behind the competition who's not the least bit confused about this.
And I'll just add a last comment, which is that energy is a very big problem. It's a very old field. But what we have at our command is advances in understanding that allow us to approach these old problems in completely new ways. And we really need to be open to out-of-the-box thinking very hard about the fact that each new innovation that comes to us in the past 20 years, vast improvements in our ability to design and create materials are now making a huge impact in what we can do with energy systems. Moving forward, we're seeing advances in biology, the ability to understand and manipulate organisms. Those will be important in energy as well. We're seeing advances in information technology, in artificial intelligence, in machine learning. All of those things are going to be applied to energy and create new opportunities, and we need to have the ability and the flexibility to look at those in new ways about how they apply to energy, and we will continue to expand and find new opportunities to make a big difference.
I just want to double down on what Dr. Wall just said. Since I was not only the director of ARPA-E, I was also the undersecretary for energy with all the applied programs reporting to me, and I looked at the budgets as well. One thing I would say is that one has to think about it the right way. Any technology, whether it's lithium-ion batteries or semiconductor chips, there's a learning curve. That means the more you do, the cheaper it gets, the better it performs. And ARPA-E's role, as opposed to the Applied Energy's role, are two different roles. The Applied Energy takes today's lithium-ion batteries and makes it better and better, better and better and better. And that's very important. That's going down an existing learning curve. That's extremely important. ARPA-E's role is to create entirely new learning curves that do not exist today. But if they're successful, they'll be disruptive to today's lithium-ion batteries, so that the competition comes from within the United States as opposed to coming from outside the United States. And this is the hedging that has been created through the applied programs and ARPA-E. And I think one has to look at the whole discretionary budget and not just the budget of the Department of Energy to see how do we want to compete in this time of pivoting of a colossal change in the whole energy industry globally. And I think you need to do both. Because if you don't do, I think there'll be a mistake for the United States.
Excellent. Thank you again to all the witnesses, especially for keeping it brief here at the end. We really appreciate it. The record will remain open for 2 weeks for additional statements from the members and for any additional questions the committee may ask of the witnesses. The witnesses are now excused and the hearing is now adjourned. Thank you.